చేసి అదే ఏమైనా రెఫర్ చేసేలా పెట్టుకుంటున్నాను సార్.
నెక్స్ట్ చూద్దాం. నెక్స్ట్ నుంచి ఒకసారి కన్ఫర్మ్ చేయండి. చార్ట్ ఓపెన్ చేసి started. Okay. You got this picture on the screen? Just once you got this second picture, then we will listen. ఈ స్క్రీన్ ఒకసారి చూడండి. ఈ స్క్రీన్ ఎస్ గాట్ ఇట్. యా ఓకే సార్. So already you understood about machine learning. I have 2 layers, and deep learning neural network we have 3 layers. More complex patterns are there in the data. Suppose I trained a model with machine learning. I got accuracy only 70%. I am not satisfied with that. That's why I tried with neural network. Think that here I got accuracy 90%. More better accuracy I am expecting. I am going with deep learning. In deep learning, nothing is different. Simply more than 3 layers will be there. In the previous only 3 layers in the neural network. Here more than 3 layers will be there. More than 3 layers. If it is more than 3 layers, that means what will be those? One input variable. That means one input layer. More than one hidden layer. Previously only one hidden layer. Now more than one hidden layer. One output layer. You can choose number of hidden layers. 1 layer or 2 layer or 3 layer, that you can choose. If you keep only one hidden layer, that is neural network. More than one hidden layer if you keep, that is deep neural network. Okay, now in this example I want to keep 3 hidden layers. Why I selected 3 in later, that technical part we will discuss. Just observe with the same example. Same, I have 3 input variables plus 1 for bias. Bias, age, weight, height. This is my target cholesterol. Now, in the first case I am keeping 6. This is my first hidden layer. And one more hidden layer I am keeping. 6 plus 2, 8 I am keeping here. 4, 5, 6, 7, 8. And one more hidden layer I will keep. But in the third hidden layer I will keep 6 only. All of you look into this one. Totally 5 layers I am involved. Between input and first hidden, I need one weight matrix. W1. What is the size of it? Left side 4, right side 6.
4 by 6.
4 by 6 is the matrix. Okay? Come on, next matrix is W2. Next matrix is W2 here. What is the size of this W2? Left side there are 6, right side 8. That means 6 by 8. Come to the W3. Between second hidden layer and third hidden layer, the weight matrix is W3. Left side 8. Right side 6. Come to the last hidden layer, which is third one, and the output layer. There is another weight matrix, W4. Left side 6, right side 1. So that the matrix size is 6 by 1. Initially, all are the random weights. At each hidden layer, prediction will happen. Again, error will be computed. To reduce that error, again in the reverse direction, it is applying errors. That means derivatives. Derivative produces delta. That delta means how much to be modified in the original weights. After that, keep on adjusting the weights in the next iteration. Again, by taking the new weights, at each hidden layer, again predictions are happening. Understand? Now, totally how many weights in this style? In this style, how many weights? In the first, for the W1, how many? 24. For the W2, how many? 6 into 8, 48. 8 into 6, 48 again.
42, sir.
48, sir.
Yes.
Again 48 here.
48.
And 6.
6.
Total how many weights? So 24 plus 6, 30. 48 plus 48, 96. 96 plus 30. 96 plus 30. How many? 126. 126 weights. Understand? Total number of weights here, 126. Now, that means in our example, I am writing the same example case. Input variables 4, that means 4 cells. Hidden layer 1. You kept 6 cells. And hidden layer 2, 8 cells. And hidden layer 3, 6 cells. And finally one output layer. Here I have one cell because I have one target variable, which is cholesterol. Got it. So now, how many weight matrices are required? Totally 5 layers. Because of 5 layers, 4 weight matrices are required. W1 size is 4 by 6. And W2, its size is 6 by 8. W3, 8 by 6. And W4, which is the 4th matrix, which is 6 by 1. Total weights. So 6 into 4, 24 plus 48 plus 48 again plus 6 into 1, 6. Totally 126 weights. So your ML has 4 weights for the same example. Neural network has 30 weights. And deep learning has 126 weights. Where is more knowledge, sir, according to this? Where is more knowledge? Come on, tell me, where is more knowledge here? More number of weights are with deep learning. That's why more hidden patterns, complex patterns that it can understand. Understood all of you? Okay. So this is what simply the difference between machine learning, neural network and deep neural networks. Of course, the deep learning, again, a lot of other techniques are there. Different types of deep neural networks, like convolutional neural networks or recurrent neural networks, long and short-term memory kind of approaches. In this way, different kinds of models are there. Even more advanced GAN models, GAN models, GAN. Nowadays, did you play something with some mobile applications? Take a current photo of you, and you can predict after 20 years how you will be. Okay. Suppose you take a old man pic. At the time he was young, how was he? You can do some estimation. Now you are youth. Your age is 21 years or 25 years. Take a pic. Submit that pic to that app. That app will say after 15 years how you will be. When you reach 70 years, how you will be. So based on the current patterns, it is going to do some predictions. So such kind of things will be done with GAN models. So GAN is one of the sub technique. That means one of the sub modeling style within the deep neural network. In this way, many things at the time of learning, you will enjoy a lot many other things. Okay. Everything is easy. Only the thing is when to use what type of model. The clarity is important. Suppose we have normal neural networks and deep neural networks. At the same time, in the deep learning, in the deep neural networks, you have convolutional neural network and recurrent neural network. When you have to use convolutional neural network, when you have to use recurrent neural network, when you have to use LSTM, such kind of clarity you should require. Once you got that clarity, for all whatever the complex mathematics we are discussing, for all these things, you have predefined functions in Python libraries. Suppose you take Keras. Keras is one of the libraries. Third-party library. In the Keras, for all the deep learning algorithms, predefined programs are available. That means predefined library is available. Only you should know how to use that library. Understand? How to train our data. By taking the data, how to, first of all, before training, you have to pre-process. You have to cleanse the data. Next step, you have to prepare input and output matrices. Got it? Once that is created, then remaining part will be taken care by the library. But which library you have to use? What algorithm? What model that I need to apply? Only that clarity is required. That's it. That's why being a data scientist, even though you are new to the programming also, you can be easily get success. Got it? Okay. Next, one more thing is there. In yesterday class, we missed that discussion. Simply, I give that discussion today. So, when I talk about machine learning or neural network or deep learning, all these things, we can train model if you have data. If you don't have data, you cannot train. So finally, these weights is treated as knowledge. Finally, after completion of the training, your models will learn these better weights. In the beginning, random weights, dirty weights, which are wrong weights. But after completion of the training, iteration 1, iteration 2, iteration 3, maybe 100 iterations or 200 iterations. Even some cases, it may take even thousands or lakhs of iterations also. But finally, after completion of the learning, how you make sure the learning is completed, learning to the model is completed. So current error, previous error, both are equal. Whenever those two things are equal, you can stop the training. Once the training is completed, better weights will be there with the model. Based on those weights, next onwards you will be doing predictions. But in all these three disciplines like ML, N and DL, without data you cannot train model. Okay? So here in all above, you can't train model. Not can, can't. Train model without data. Got it? Okay? There is another discipline, reinforcement learning. Here, model is called agent. Terminology changes. Model is called agent. Some queuing algorithms will be used. What are those algorithms? Once we step into that one, easily we will be learning. Okay? So model is called agent. Agent will learn. Agent learns from environment rules. That means two things we need to create here. Not the data. Two matrices we need to create. Number one, rule matrix. This thing technically called as environmental matrix. Two, knowledge matrix. The other name, technical name for this, Q matrix. Initially random knowledge, no knowledge. But as it starts journey in the environment is giving, depends on the actions it performs, environment is giving rewards. Come on sir, a small example. Observe the traffic system. For some time you are not a human, you are a robo. Okay, think that you are robo Mr. Rajnikant. Think that in the beginning you don't have any knowledge about the traffic rule system. Okay, now you started journey in the environment. Red light on. What is the rule?
Stop.
If red light on, what is the rule? You have to stop. But you don't know, you are a robot. First time you came to this environment, you don't know that rule. Okay, then immediately police caught. That means police caught you means he has given one reward, negative reward. Okay, then you will be learning from that. From that negative reward, immediately you will be learning. Okay, when our red light is on, then you have to stop. Understand? Previously your queue is dirty, almost zero knowledge. You traveled in the rule matrix, that means environment. In the rule matrix you are performing actions, going left, going right, going speed, or going very slow, going right, taking U-turn. All these are the actions. Understand? For every action, if action is correct, positive reward. If action is not correct, negative reward. Suppose in our home there is a pet dog. You gave one task, it performed the task, you are giving 2 biscuits as a reward. And you gave one more task, but it did not well, you are hitting that task. You are hitting that dog. That is punishment. Negative reward. For every action, based on whether it is correct or wrong, that agent is getting some reward. Maybe positive, maybe negative. Based on the rewards what it is getting, depends on that. Always it is trying to improve the number of the rewards. To improve the number of the rewards, number of positive rewards, it tries to reduce the mistakes and better understands about this environment. And always try to perform perfect actions, which are correct actions. Because its goal is not to perform the correct action. Its goal is to take more and more rewards. Understand? On that way, even though without data, without past data, your models can learn. In reinforcement learning, these models are called agents. Understand? That's why for all the artificial robots, they are putting a name, agent. Understand? It is able to do self-learning from the environment. In the environment, rewards will be there. Based on the actions it performs, the environment is giving rewards. That is what rule matrix. Based on the rewards what it received, it is trying to increase the knowledge. In this way, after 1,000 actions in the rule matrix, after 1,000 actions in the environment, your robot will become super strong, better than a human. That is why nowadays in the chess games, even world most top chess champions are not able to defeat these robots. That too, those robots are able to defeat the world most topmost champions within the seconds time only. They are not taking hours of, they are not killing hours of time. Because if you allow a robot to play the chess for 10 minutes or 20 minutes, it will learn all the things. If it start playing with 20 people, even though in the beginning it doesn't know chess, but after playing with 20 people, it started learning and it will become more efficient. You want to build such kind of self-intelligence systems. Understand? At that time, this reinforcement learning. Same style, you have NLP and RL. By using the combination of NLP with the reinforcement learning, already yesterday a class I explained importance of NLP. NLP can do two things: text pre-processing and feature creation. That means text features into numerical feature conversion. There are different techniques for that. Got it? With the combination of NLP and ML, you can do the predictions. With the combination of NLP and deep learning, you can do more complex predictions about the textual data. But with the combination of NLP and reinforcement learning, you can develop chatbots. What is the importance of a chatbot for the organization or for any application or for any website? For example, I have a business, training business. I have counselors also to answer our questions. But my counselors are available only after 10 a.m. to 5 p.m. Once 5 p.m. completed, they will be leaving. If you call to them, they are not available for the calls. For example, in the midnight if you call, no one is available to answer you. If I deploy a chatbot in my application or for your organization, now you have a query, ask that chatbot, immediately that will reply. Suppose one student is asking, one lead is asking, when will be the next data science batch? Automatically my chatbot will say answer for it. What I am expecting from a human, same thing, on such way I need to train this chatbot. Understand? I need to train this chatbot. So what will be the timing, next batch timing? It will say answer. What is the course fee? It will say answer. Understand? Is there any discount? It will say answer based on past 2 days students discount based. Most of the past students, maximum on average how much discount is applied, depends on that, automatically takes the dish. Like this. Okay, such kind of applications if you build into one, without human, it will say a lot of answers. Of course, it's not a complete replacement to the human. Just 1 or 2 guys have to keep on monitor these chatbots, whether chatbots are giving perfectly answering or not. and what information always we should supply to the chatbots, that will be taken care by other team, generally back office team. Okay, with the new questions, new answers, automatically it will be doing learning. On that way you can use combination of NLP and reinforcement learnings. Got it? But when data is very bigger volume, very bigger volume, like basically you have seen how gradient descent algorithm works, that means how machine learning models will start learning. Iterative algorithms in the first iteration, second iteration, third iteration, every iteration it is trying to keep on reducing the errors. It may take 1000 iterations or it may take 2000 iterations. Sometimes for some big volume of data it may take lakhs of iterations also. But if I have terabyte of data, or 5 terabyte or 10 terabyte of data, so on that much, with that much big volume of data I want to train my model. In this case, not lakhs, sometimes it may take billions of iterations also. Just only for the training completion of the model, it may take 1 month time or 2 months time also. But you don't have that much time. That's why parallel processing systems are required. Parallel processing systems are required. Distributed data science algorithms are required to the industry. Not data science algorithms, distributed data science algorithms are required. That means same model training should be taken care by multiple systems parallelly. Understand? Suppose your biggest volume of data is distributed into 100 machines. If single mission does the work, it is taking 10 hours time. If 100 missions parallelly does the same work, some piece of data by system 1, some other piece of data by system 2, some other iterations by system number 3. On that way the number of iterations are distributed. Then your time will be 10 hours divided by 100. 10 divided by 100 means 0.1 hour. 0.1 hour means 6 minutes. Previously with the normal system, the model training took 10 hours time. Same with the distributed parallelized processing system. The same work will be completed within 6 minutes. Okay? To support that work, there is distributed processing system called Spark. To parallelly process the data with in-memory computing with high speed. In that Spark, there is a component called ML. Spark ML. If you are a big data engineer, you need this Spark ML also. Okay, suppose normal data, normal volumes, no need of this Spark ML. With normal core libraries of the Python or R language or SAS, statistical analysis and systems. With these kind of languages you can perform all the processes. But Python is very popular. R also could able to do that, but most of deep learning and machine learning applications are developed or trained with Python kind of languages. But still R can do that, SAS also can do that. But Python is more efficient because it has very rich set of libraries. Got it? So today, as part of this session, I just discussed about all the products overview. But all the different sub-disciplines will be there, like statistics, machine learning, neural networks, deep learning. And we did a discussion on NLP, reinforcement learning, NLP and reinforcement learning combination. By the help of this NLP and reinforcement learning combination, you can develop even chatbots also. Okay, that too AI based chatbot. Chatbots already there. You can develop AI based chatbots, artificial intelligence based chatbots. How human is replying on the same style, the chatbot has to reply intelligently. Not with the not like a fixed question, fixed answer, fixed question, fixed answer. It should not be like that. How human is thinking and then replying on the same style, your chatbot should be able to think like a human, reply like a human. Again, there are different techniques: voice to text conversion, text to voice conversion. That too, nowadays the chatbots are being developed in such a way, multilingual chatbots. Suppose I don't know English, you know English, I don't know English. How we can communicate? Generally by taking help of some translator, some human translator. If there is a device, you are speaking in English, the device is translating me into Telugu. Again, I am speaking in Telugu, my device is translating that Telugu into English. Okay, such kind of multilingual products also you can develop. Got it? But it's not easy task. A lot ways of training has to be done to your models. Got it? Even OpenAI people have developed ChatGPT. Really, ChatGPT, if you really do a trial with that ChatGPT, you will be amazing. Hundreds of people involved into that ChatGPT development. Ask any technical question, that is explaining better than our faculties. Better than our faculties it is explaining. Of course, only 20% of development is done for the ChatGPT. With 20% only, this much result it is giving. Just assume if it is really developed with all the features, remaining 80% is also added into that one. And tomorrow if voice is also added into that one, that too multilingual support is already available to that one. Then what about next level of technologies are entering into this one? Understand? In this way, this data science and machine learning, deep learning, that means artificial intelligence is going to enter into lot many domains. Not only into this particular banking or insurance, not like that. It's entering into everywhere. Understand? So next level of course, it cannot remove the human jobs, but human jobs have to be transformed from one type of shape to other type of shape. Understand the point? Okay? So next Saturday onwards, we are going to step into. Yesterday and today we have taken overview of all the things, and come to the next Saturday, the Saturday and Sunday, we are going to start the journey from the statistics onwards. Don't worry whether you have statistics background or not. It doesn't matter to you. Okay? So how much statistics is required for the data science and for the artificial intelligence? All the things from basics to up to all the required things you will be learning. Even though that thing is complex, I promise you, I will make you easy. Okay? So on that way, each and every model we will understand. After that, we will implement the same thing with different languages like Python or SAS. So majority of the priority I give to the priority to the Python. With the remaining languages also I will demonstrate this. Okay, already SAS trainings are separate and Python trainings are going separately. Okay, so you people can attend those sessions also, right? Okay sir, thanks very much. Thanks for spending time with me. Let's meet in the next week, sir. Okay, thank you. It is live streaming, connect streaming software. Where to end this meeting? There is end option here to end the stream. సుహాస్ ఒకసారి చూడేది ఇక్కడ స్ట్రీమింగ్ స్టాప్ చేయాలి. బటన్ లేదు, అది ఎండ్ స్ట్రీమ్ చూడు. ఇదే ఎస్. So before streaming every time we need to start this application.